Welcome back to SWAYAM course on design thinking and innovation. This is week 13. We are looking at tools. We look at how human factors or ergonomics is a very important part of design and innovation. We'll also look at systems level mapping to get an overview of the problem that you're trying to solve along with its components. Also move into high fidelity prototyping, that is even finer method of prototyping, and then take it forward through 3D physical modeling as well as 3D digital modeling as well as digital printing. Okay, so details on this will follow. So section T13, week 13. So we look at human factors ergonomics, systems mapping, high fidelity prototyping, 3D model and printing. Those are the topics to be covered. So let us look at what is human factors and ergonomics. This we covered in the first part in the process section. Human factors, also known as ergonomics, is the science of understanding our capabilities and limitations and its application for the design of products, systems, spaces, services, etc. If you look at the definition by the International Ergonomics Association, it says ergonomics as the scientific discipline concerned with the understanding of the interactions among human and other elements of a system, and the profession that applies theory, principles, data and methods to design in order to optimize human well-being and overall systems performance. Okay, so we are going to go into details of this. Okay, so if you look at it, okay, let's look at where all we make use of this, or you might need this. Let's take the case of a knob, the door knob, the knob of a door. When you have to design it, would you keep the child in mind? The elderly, make it easy for them to turn it or push it. Okay, and how about a person with some disability? Yeah, so these are the factors that need to be taken, especially from a human factors point of view. Let's look at wayfinding systems. You're trying to locate direction to go somewhere. What it is, how would the child read a signage system? How would the elderly with not that great a vision, okay, have a look at it, okay, or persons with who doesn't know how to read and write or has readability issues, how do you actually get the information? Okay, so these are the considerations from a very human well-being point of view. Or let's take medicinal instructions. Okay, when you go and buy a medicine, maybe it's on the packaging. Okay, how would a child make out what it is there? Is it readable for an elderly? These are the larger issues one needs to look at. Toys for children, softness, the role of edges, colors, materials plays a very important role. If you need to design cooking utensils, how about for a person with low vision? Or do you need to do something else because the elderly are going to use it? Okay, how about mobile for the elderly? Okay, the size of the touch interface actually increases. Okay, size of the text needs to be enlarged. How do you actually enable these kind of things? Okay, safety for women. Okay, would public lighting affect or bring in this at least the feeling of safety? What are the emergency options available to them? Okay, are systems that are safe socially? Okay, so these are the broader questions, and human factors are there specialized in trying to solve some of these problems or mitigate some of these issues. Okay, so we look at three types of ergonomics: the physical human factors or ergonomics. It has to do with the physical capabilities and limitations. The measurements of humans is called as anthropometric. It looks at the postures that you need to take in the workspace, the ambient conditions like the lights. Okay, if you have to read, the visual ergonomics of it. Okay, the next is cognitive or human ergonomics. Okay, and it has to do with memory, how much attention spans do you have, how does perception play a role in it, how does emotion play a role in it, what are the typical motor response timings, how information gets processed, and what is the limits and capabilities of information processing. And all this becomes very, very important when you apply it to human computer interactions. Okay, and the last one is organizational, human factors or ergonomics. It has to do with what happens when you work in teams, what are the social interactions, how to make it collaborative, design of workspaces to make it conducive for people to interact with each other, okay, and lighting, the spatial configurations, all of them make a difference. Okay, so let's look at physical human factors and ergonomics. International Ergonomics Association defines that as that is concerned with human anatomical, anthropometric, physiological and biomechanical characteristics as they relate to physical activity. The relevant topics include working postures, materials handling, repetitive movements, work-related musculoskeletal disorders, workspace layout, physical safety and health. Okay, so it covers a lot of areas where your measurements, your physical abilities are very, very important. Okay, so you can see that it's very, very important, especially when you're designing some of these. Let's say you're doing a product or an automobile design, also a machine design like a lathe, right? Design of it, where the knobs are, what the sizes has to be there, does the person gets confused or is it very clear, what are the emergency procedures, for example, readability issues in communication design, whether it's publication design or signage systems. Okay, communication design has a vast variety of applications. So how does human factors play a role in it? Okay, and how about workspace design, considering postures and workload? Okay, so whole lot of areas. Okay, so let's look at some of the examples here. So anthropometrics is the science of measurement of a person's body in terms of its dimensions, weight, shape and form and functional capabilities while in different postures or age. Okay, so age matters, gender matters. Okay, capabilities matter in terms of dimensions, weight, yeah, and all the things. Since the dimensions of the human being change and vary, it is important to consider this factor while making use of anthropometric dimensions. That means it's different for different contexts. So very, very important factor. So here we are, saying please refer to the well-researched book by Professor Debkumar Chakravarti, titled Indian Anthropometric Dimensions for Ergonomic Design Practice. Okay, especially if you're designing for people in India, in the context in India. Okay, so please refer to this book, very useful book, especially when you have to fix the dimensions and proportions and lighting conditions and things like that. Okay. So here, for example, we saw this case study before. It's for storing and transporting vegetables. Okay, you can see the container, has the human, body dimensions have been taken into considerations while, fixing the dimensions of the packaging unit. Here, for example, the person is designing a lounge furniture chair out of bamboo. So your posture when you're relaxing matters a lot. Okay, so you can see the dimensions suited to the Indian, human being. So let's look at the steps, the different steps in applying this. First, finalize the prototype of product or workspace or service. That's your design. Select the context. Okay, what posture, what age, what sex, what environment. It is important as the human dimensions vary according to the above factors. Okay, here we say please refer to the anthropometric dimensions appropriate to the user segment. For India, we have already mentioned, refer to this particular document, okay, or documents which are sorted for Indian context. Now apply these dimensions to the prototype. You can also get it tested and get feedback from the users. Okay, getting feedback and reiterating it after testing is a very, very important part of the process itself. Okay, so these are the different steps, 5 different steps in applying physical human factors or ergonomics. So let's move on to cognitive human factors and ergonomics. Now the International Ergonomics Association defines it as that is concerned with mental processes such as perception, memory, reasoning, motor response as they affect the interactions among humans and other elements of a system. Yeah, so very clear, right? There's a connection between cognitive ergonomics and the mental process. Okay, so that connection is very, very important, and some of the things that need to be considered are mentioned here. Okay, so for example, if you're working, what is the mental workload, how to take into considerations aspects of decision making, skill performance, human computer interactions, okay, human reliability, how to take care of work stress and training, as these may relate to human systems design. Okay, so you can see that if you want to apply it, is some of these are some of the application areas: user machine interface, controls of a system. It could be automobile, airplane, power stations, traffic controls. Okay, one of these, signage design, packaging design, all of them cognitive human factors can make a big difference to them. Okay, so we are trying to look at few of the laws that you can actually make use of. Okay, the first one is the Gestalt laws of proximity and similarity. This was by psychologists working in Germany, and they came out with many laws, but we are just talking about a couple of them here: proximity and similarity. So the proximity law says that the closer the objects are to each other, more likely you perceive them as a group. Okay, so you can see that there are 3 circles followed by 3 circles and 2 and 1, right. It's very tough to perceive the 3 as a group, but if you look at it vertically, right, they seem to be 3 groups, 1 with 2 vertically, 1 with 3 and 1 with 4. Okay, that's because they are closer together vertically than horizontally. Okay, so this is a law on similarity. Objects or elements that are similar are like to be grouped together. Here you can see that similarity has come through color. Sometimes similarity has also come through the shape. Okay, so it's very easy for you to perceive the blue circles, okay, the squares which are in the middle, the green circles as belonging to the same group or family as against the vertical ones. Okay, the horizontal is perceived as a group much more than the vertical ones, because the vertical ones are different from each other. Okay, and how to use these laws, Gestalt laws of proximity and similarity. One immediate application is design of a web space. Where do you want your eye to move? How do you want your eyes to move when you are looking at a web space? Do you want them to look at it vertically or horizontally, or both vertically and horizontally? Yeah, so this is something that you can do by applying these laws. Okay. If you put the things together, then you know that that forms a group. If you put the vertical elements together, then your eye would actually automatically move vertically. Okay. And if you put them horizontally, then the eye would move horizontally one by one. Okay. It leads to less ambiguity, okay, very easy to identify, okay, and it leads to visual organization and the way actually you move your eye itself. Okay, so this is an example of a signage system. Okay, and you can see that the first floor has been colored differently from the second floor and from the third floor. Okay, color is similar. Also, you can see that proximity also plays an important role. Okay, for example, the first floor and the second floor has a gap. All the elements in the first floor are together, all the elements in the second floor are together, and all the elements in the third floor are together. Okay, so if you look at it, both proximity and similarity has been used to create this signage system, which could be as you enter the building, you see it, and then you can easily find out where your the office that you are looking for is. And there are also color codes to remember, because when you get out of your lift, maybe it's green outside, so you know that I've come to the second floor, right? And let's look at it from a design of a layout for a magazine. Okay. Or it could also be for a web space. Okay. So, if you look at it, okay, the ones together seems to be the horizontal connections. Okay. So, your eyes, because they are based on proximity. So, you will see that your eye will move from 1 to 2 and then go to 3, then 4 and 5 and then 6, 7, 8. 6, 7, 8 are also similar. Okay. So, you will see them as a group. Okay, whereas the other ones are dissimilar, but because of the proximity, your eye will start moving in this direction. So, your design can actually make the person move his eyes or read the article as you want him to read. Okay, so that's the use of the Gestalt laws here. So, let's go to Hicks law. Okay, it's on the number of choices that you make. Okay, it's very interesting if you look at it. Okay, states that the more number of choices a person has, it takes a person longer to take a decision. Okay, so the solution is not to provide everything, all the alternatives, because the person can easily get confused, or he'll have to look at all the options and then only make a decision. Okay, or the other way around, the less choices means less time to make a decision. Okay. So, if it is possible for you to reduce the numbers like in option 2 as against option 1, that seems to be a better idea. Okay. Application of this law leads to faster decision making and simplifies choices. Let us say you are driving an aircraft, okay, and and you have to take a decision very fast. Okay. So, if you have too many pointers in front of you, okay, dials in front of you, and you have to look at all of them to take a decision, it's too long. Maybe the ones which are very crucial in this situation to be looked at would make it easier for the person or the pilot to take a decision. Okay, so, let's look at another law, Fitts law on size and distance. Okay, Fitts law on size and distance says that the amount of time required for a person to, let us say, move your eyes from position 1 to position 2, okay, depends on the distance and the size of it. Okay. So, it's in the first one you see the blue circle has reduced in size. Okay. So, it's immediately not possible, but in the second case you will see that the size is increased. So, the target is very easy to identify. Okay. So, it will take longer if the size is smaller and the distance is also longer. Okay. So, we have shown 2 examples. Again, it saves time, okay, and you can make faster decisions. That is the Fitts law. Let us look at Murph's law. Okay. He says a very interesting statement on the law of wrongs. Okay. States that anything that can go wrong will go wrong. Okay. Or the other way around, the less complex the solution is and the less the number of components or steps, the system has better chances of working. Okay. So, that is the other way around. In the option 1, there are too many things. Okay. So, the chances of many of them going is much more higher than the next option, which is just 3 components working. Okay. So, yeah, it leads to being careful. Sometimes you do not know where to go, so a reconfirmation message makes a big difference. Okay. So, designing to rectify the assumption that it might go wrong is itself a good design decision making. Okay, so that is Murph's law on wrongs that can happen. So let us look at this example here. I think almost all the laws are applied here. The Gestalt laws on proximity is applied here. The buttons which are together, okay, or you'll see them as, perceive them as similar. Okay, Hicks law, okay, shows that the most important thing are shown first. So the top row is important, and it is used Hicks laws to make it there. Fitts law says if it is larger, when you move from one to another, it makes it easier to identify it. So these buttons are really large. Okay, so to adhere to Fitts law, and it makes it comfortable also to press on top of it. And Murphy's law, which says that and you've actually done an operation, but you don't know whether it is completed or whether it has hung up. Okay, so a reconfirmation coming saying that, oh, you completed this message, or now you completed that, go to the next one, is actually reaffirmation that the work has been done. Okay, and it makes it easy to take decisions. Okay, so we just looked at all the 4 laws here. Okay, and this is applied to the interface for a controlling device for the bedroom, which we saw as a case study some time back. Okay, so we will move on to the next section, which is to do with systems mapping. So, we are asking this question, what are system maps? Okay, system maps are kind of similar to concept maps, which we did in week 10 under tools, and depict how the design solution is interconnected to its components or other parts of the solution. Okay, so it is a broader view of, it gives an overview or a broader perspective of this interconnectedness. Okay, and it is as a visual representation. Let us look at some examples. Okay, so we were doing this project in Singapore, and the project's name was called as the Cosmic Project. Okay, and we are giving you a systems overview of it. The intention was that this will empower the next billion. So, it is meant for a lot of people. Okay, so if you look at it, on the top are social media platforms, components of it. Okay, and it is backed up by information systems platform. Okay, so they both work in together to actually bring out many applications, okay, which has to do with different fields like agriculture, health, okay, and other verticals. Okay, and if you look at it, at the middle is a platform, okay, which is basically the cloud platform to do it. And before that, we needed to understand this user segment itself. Okay, the middle of the pyramid, what do they mean? Okay, what do they have? Okay, so we had to do pilot and detailed studies to understand the needs and wants. Okay, so that was the people's dimension. Okay, because that was what the project was supposed to do, and we actually made use of technology to build this system. Okay, so I can explain and give you an overview of the Cosmic Project by connecting all the components which are part of the system. Okay, they are all interconnected if you look at it, right. Yeah, and finally, the applications that you need to be useful to the people. Okay, so this gives you an overview of the system. This was another project looking at the email interface. Okay, you get a login and you have a the communication window which shows all the emails that have come in, right, and they could be in folders, okay, and some you want to put it into a trash and so on and so forth. Okay, but what if when the email comes, it gets filtered and puts it into different clusters. Okay, and these clusters could be ranked. For example, if the cluster is, let us say, my family, it can learn over a period of time, okay, these people are part of his family and these people are part of his working group. Okay, and he is doing a new project, these are the people connected with the new project. Okay, so if you look at it, okay, so the clusters have a ranking in them. Okay, and it can be ranked so that the ones which are important comes to the top, and that becomes the inbox for you. Okay, so if you look at it, these diagrams are an overview of what you're trying to do and explain your concept in a jiffy. Okay, you can go a little more detail into it. Like here the group was looking into the household consumption of energy. So they have put all kinds of energy, renewables, non-renewables, what is the household consumption, okay, what is the technology being used to it, okay, accessibility issues. Okay, the whole thing is linked together, interconnected, so as to give you a overview of this particular issue. This is a case for healthcare. You can see that it's a lot more complex and lot more detailed. Okay, there are direct relationships, there are inverse relationships, okay, and there are sometimes systems delay in implementing it. Okay, so this is an extremely detailed map of it. But what I was trying to say is that you can see that different components of system are linked together, and you can actually talk to people and show them this is what you meant by it, and also it's very useful for problem solving itself, because at a glance you know the components of your system. Okay, so from here we will move to the next topic, what is high fidelity prototyping. High fidelity prototyping is the final version. You know, it almost looks like the one that you wanted in terms of shape, color, texture, resolution and functionality. Okay, it's almost correct, but it's not actually full working one. Okay, it's still a prototype, you know, it's a mock-up prototype, but it looks like it can work. You can also put in features where partly it can work, like proof of concept, yeah, and you can get really nice feedback on this. This is, you know, as I said, it's great for getting feedback from its users, as it's almost like the final version. Okay, and digital versions of high fidelity prototypes are easier to make than the 3D prototypes, okay, especially if you have interactive features, it's even more complicated to make. Okay, so high fidelity prototypes are great for prototyping publications, digital interfaces, packaging solutions, card and board games. Yeah, so let's have a look at few of them. This is as applied to the smart device in the bedroom. You can see the different screens, and you can actually make somebody go through these screens and give you a feedback on this. Yeah, so this is the same thing, smart device for bedroom. It almost looks real, you know, except that the programming really doesn't happen at the back of it, but you can actually test the interface in terms of its elements and things like that. Here you see a packaging design prototype is being done, it's the correct size. Okay, so you can hold it in your hands. It's still doing at the alternative level, okay, but it feels like you know what the actual, you know, packaging is like. Okay, and here for example is a simulated one in the design of signage system for suburban railways in Mumbai, and you can see how it should be. All the final ones are, you know, high fidelity prototyped and put on, you know, mapped onto the actual site. Okay, so it almost looks like the final version. Okay, we move on to the next topic, 3D modeling, both physical and digital, as well as 3D digital printing techniques. It is used for creating objects in 3 dimensions. The 3D modeling could be created physically, digitally, or 3D printed digitally. Okay, so these are the 3 objects. When you do physical 3D modeling, you can use many materials from cardboard to wood to metal and plaster. When you do 3D modeling inside a computer digitally, you can use many techniques to do it. Some of them are called solid modeling, wireframe modeling and surface modeling. Okay, and 3D digital printing allows you to make 3D objects using various materials. There are many ways and methods of doing this. Okay, but you know, all these 3 are different techniques for creating 3D objects. Here for example, you know, the original material is a combination of foam and plaster painted almost to look like it's the actual, you know, final model of the two-wheeler. Here the student was exploring different concepts in lounge. Okay. You can see the 3D model has been done. Okay. So, he can test out his ideas. Okay. And you can see this is a digital version of it. Okay. It almost looks like the real one. It's good to get visual feedback on this. Okay. Here's another one, 3D model of it. This is the spline lounge concept. Okay. So, here you can see these are printed models of how Indian temples makes use of fractals. Okay. It's 3D printed, a small size, but you can actually see the principles which are used in making of these temples, and you can actually fit them together. Okay, so let's look at why do we need prototyping, powerful techniques. Okay, we've gone from human factors and ergonomics, a very important aspect of it, to doing system mappings. Okay, and then doing high fidelity prototyping, to doing 3D modeling, physical, digital, and to digital printing techniques. So, thanks a lot for listening to the tool section, section 313, week 13. Just summarizing the week 13, we go from process, we finish that. Then to the tools, we just finished the human factors, ergonomics, systems mapping, high fidelity prototyping, 3D modeling and printing. Now, we will apply it in the project section, followed by the case study. That is the design of bamboo sliver furniture.